All right, so we are going into part 2 of 1.4. Okay, and so let's go ahead and get started on that. We're still dealing with quadratics. So let's go ahead and get into that piece. All right, so here is our, hopefully that's sharing now. All right, so part 2, solving quadratics. This time we're going to be doing by completing the square. Okay, a different little term. And then also something you probably remember, which is quadratic formula. All right, so if you look at this problem, x squared, which is a quadratic, minus 6x plus 14, okay? Well, if I look at numbers, 1 and 14, 2 and 7, does any of those be able to add or subtract to get you to 6? No. Okay, so this one does not factor. Okay, so we can use what's known as completing the square method. Now, little thing though, okay? If something factors, if it factors, yes, you're going to get rational answers, whole numbers or fractions. If it doesn't factor, you're going to get either irrational and or imaginary. Okay, so this one does not factor. So it means my answers are going to be irrational or imaginary or both. Well, technically they can't be both, but they'll look irrational. Irrational means it's going to have a square root symbol in it. All right, so got a few steps here that I have you down. You just want to stop for a second. You can write them out. But to complete the square, we're going to do a few things. One, make sure the lead coefficient is 1. Okay, this is the lead coefficient, so it is 1. Move any constants to the other side. So here's a constant. It's 14. So it needs to move to the other side. So I'm going to have x squared minus 6x is equal to negative 14. Now, one of the things I teach when you do move those to the other side, I say put some blanks in. So we're going to go plus a blank, and you're going to see what we're going to use with that here in a second. Okay? So we're going to now take b over 2 and square it. Now what's b? Well, this is b is 6. So we're going to take 6 over 2, and it can be positive 6, it can be negative 6, it doesn't matter, because when you square it, it's going to be positive anyway. So that's 6 divided by 2 is 3. 3 squared is 9. Now, that number 9, this number 9 right here, goes into each of these blanks to keep it balanced. This is what we call completing the square. Okay? And the reason we can complete the square is if we go down here, this is going to be negative 5. But what this becomes is, if done properly, you're going to get a factor that's a perfect square. In other words, we're going to get two factors that are exactly the same. Because what number multiplies to 9 that adds up to negative 6? Negative 3 and negative 3, which would be the same thing twice. So it completes the square, which is x minus 3 all squared. That's what completing the square means. Okay? Then it says to use square root method. Okay, so last step, use square root method. So how do I use square root method? Well, remember, if I have something squared, you're going to square both sides. Square root both sides. Okay? So this is going to be x minus 3 is equal to plus or minus, so the square root of negative 5. Well, what's the square root of negative 5? Well, that's plus or minus I root 5. Now remember, that plus or minus came in when I square root both sides. Anytime we square root both sides, you get the I, or you get the plus or minus, excuse me, plus or minus. Okay, the I comes from the negative, and then I have x minus 3. So now I'm going to isolate the x. So x, we're going to move the 3 to the other side. We're going to put it in the front because it's a regular term. Plus or minus I root 5, which is a complex number. But there are two answers, a plus version and a minus version, which brings me to what WebAssign will make you write down. This is when WebAssign is not very cool. it would be x is equal to 3 plus I root 5 and 3 minus I root 5, comma in between. Okay, so that's how you'd have to write the WebAssign answer. Okay, again, that's why it's important to watch the videos. All right, so let's look at one more example. Okay, so we look at this example. Notice the front term is a 3. I want the front term to be a 1. So what we're going to have to do is we're going to divide everything by 3. Okay, which gives me x squared plus 5x minus 10. Now, I have the 1 in the front now. I got to move my constant over. So the 10 goes to the other side. So this is going to become x squared plus 5x plus blank is equal to 10 plus a blank. And that blank is that be that complete the square problem. Now here's where this gets a little weird, okay? Because this is an odd number. So to find b over 2 all squared, we got to go 5 over 2 and square it. Well, 5 over 2 squared is 25 over 4. So this is going to be 25 over 4. 25 over 4. That's all I can do. I'm going to give you a shortcut. To complete the square, it's going to be x, because this is a plus, this will be a plus. And then this number right here is always the square root of this number. You look back up here, the square root of 9 is 3. So the square root of 25 over 4 is 5 over 2. Okay? Now we do have to add this side over here. Your graphing calculators will do this. If not, 10 is the same as 40 over 4 plus 25 over 4, which would be 65 over 4. So this is 65 over 4. I'm going to leave it like that because we got to square root both sides. So this now becomes x plus 5/2 is equal to plus or minus. Now this is the square root of 65 over the square root of 4, which square root of 4 I know is 2. 65 is 5 and 13. So that's just the square root of 65. And now to isolate, we're going to move the 5/2 to the other side, but we're going to put it in the front. Negative 5/2 plus or minus the square root of 65 all over 2. Okay, I just leave it like that. WebAssign would make you do it 5/2 plus the square root of 65 over 2, comma, negative 5/2 minus the square root of 65 over 2. And again, WebAssign is not nice without the plus or minus, since it does not have a plus or minus on. All right, so that's how you complete the square. Okay, so now let's talk about how to use quadratic formula. And most of you have probably used quadratic formula before. The other thing I want you to notice is we have the same exact problem, so I should get the same answer. Okay, so let's look at this. To do quadratic formula, you do not have to memorize this. I will give this to you. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If, and you have to have it in standard form, because I need to find a, b, and c to plug into your formula. So you're going to find a, which here is 1, b is negative 6, and c is 14. So in this purpose, you're just going to plug everything into the formula. It's already solved for x. So we're going to go negative b. So if b is negative, that means negative b is positive, 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 14 all over 2 times 1, which is going to be 6 plus or minus the square root 36 minus 56, it looks like, all over 2, which is 6 plus or minus the square root of negative 20 over 2, which the radical then simplifies, 6 plus or minus 2i root 5 over 2. Now, this does reduce, but for it to reduce, all three of these parts have to have something in common. They do. A 2, a 1, a 1, and a 3. So I get 3 plus or minus I root 5, which, if you remember, was the answer we got last time. All right, so one more time. Let's figure out what we have here. So A is 1, B is 5, C is negative 10. Okay. Now this would work if I use the other numbers too. They'd just be bigger. So x is equal to negative 5 plus or minus b squared minus 4 times a times c all over 2 times a, which is negative 5 plus or minus 25 plus 40 over 2, which is negative 5 plus or minus the square root of 65 all over 2. Now, the way we wrote that answer on the previous problem was negative 5 over 2 plus or minus the square root of 65 over 2. These are the same answers. Just one is broken up into 2 fractions, one is broken up with just 1 fraction. Okay? So that's quadratic formula, and it would have worked with the original one that we did on the last problem. All right, so one other thing about quadratic formula we want you to know, and it's what's called the discriminant. The discriminant is labeled as b squared minus 4ac. It's this part of the quadratic formula without the radical. It's the inside piece. Okay, it's the inside piece. And if we can figure out that number, okay, we get some answers here. Like if you go up here, the discriminant for this problem, okay, is negative 20. The discriminant for the second one was 65. Okay, now what does that value mean? All right, so if the discriminant is equal to 0, you are going to know that you're going to have one real rational solution. And I know you're supposed to have 2, but that one real actually in mathematics counts as a double. Okay, and we'll talk about that more when we graph. Okay, if that number, that discriminant number, is greater than 0, up here, 65, greater than 0, right? Or in other words, is positive, you're going to get 2 real solutions. Now, they may either be rational or they may be irrational. One of the two. Okay, they're rational, okay, if that number is prime. Or no, excuse me, if that number is a perfect square. They're irrational if they're non-perfect squares. Okay, and an irrational just means the answer is going to have a square root in it. Okay, now, where did we have one of those? Well, the one above had a square root in it. Well, this one here, the 65. This is a square root of 65. 65 is not a perfect square, so that's why I got 2 irrational solutions, because that 65 was bigger than 0 and not perfect, so they're irrational. So you have a square root. And then the last one, sorry about the mark here, the last one is, what if this number is less than 0 or negative? Whoops, sorry. This should be positive here. The positive value here, or a negative value, which is less than 0, correct? So if it's negative, you're going to get 2 non-real solutions, which happen to be imaginary. And that would be up here. Notice the discriminant on this one up here was negative 20. So if the discriminant's negative or less than 0, I got 2 imaginary solutions. There's my I, plus or minus gives me 2. So that gives me your last one in that. Okay, so I hope this helps for part 2. We got one more part to do.